Okay, last video of the unit. As you guys prepare for your test, we are looking at solving more equations, and in these situations we're solving rational equations. You can see that you have these things in the denominator. And in order to solve these, what we like to do is we simply like to find your common denominator. In this case, it will be n minus 8. So 1 over n minus 8 is good to go. I'm going to rewrite 1 as n minus 8 over n minus 8 is equal to 7 over n minus 8. Now in this situation, I know it's going to sound strange, but you can in fact at this time completely ignore the denominator. And what I want you to think about is this, is that if it's an equation and all the denominators are the same, then you just have to focus on the numerator being the same. So we're going to solve that 1 minus n minus 8 is equal to 7. Now, the only thing that we need to keep in mind for the denominator is we can't come up with n equal to 8. If we came up with 8 as a solution, then we would say that would not work when you plug it back in because you get 0 in the denominator. We call it an extraneous solution. So we are going to simply focus on the numerator now at this point. A little trick there. Maybe you missed the negative in front of the n minus 8. And with a negative n, 1 minus negative 8 is positive 9 is equal to 7. So negative n is equal to negative 2, n is 2. So that's my solution. And I did not come up with 8, so that's good to go. If you were to plug it back in, you get 1 over negative 6 minus 1 is equal to 7 over negative 6. And if you check that out, negative 1/6 minus 1 is negative 7 over 6. So in fact, n equals 2 is your solution. In this situation, my common denominator is going to be x times x plus 2, as you see this portion factor. So I'm going to rewrite the 1 as x times x plus 2 over x times x plus 2 equals, we have 1 over x times x plus 2 plus, and then this one I have to multiply the top and bottom by x plus 2. We get x minus 1 times x plus 2 over x times x plus 2. So the denominators are the same. We cannot come up with, x cannot be 0 or negative 2. As long as we don't come up with those solutions, we're fine, because that would give us 0 in the denominator. But in the numerator, you can see that you end up with x squared plus 2x is equal to 1 plus, and then here we get x squared plus x minus 2. And now this problem becomes very simple. As we subtract x squared from both sides, we get 2x is equal to, let's see, 1 minus 2 is negative 1. We have an x. If we subtract the x over there, we get x is equal to negative 1. And so that's our solution. We didn't come up with 0 or negative 2. X equals negative 1 is our solution. In example C, you can see that this is also rational. If you have a fraction equal to fraction, though, you can always just cross multiply. Just note that x cannot be equal to negative 1. That would give you 0 in the denominator. But as you cross multiply, we get x squared minus x minus 2 is equal to 6. X squared minus x minus 8 is equal to 0. That does not factor. And because it does not factor, we use the quadratic formula or we complete the square. The quadratic formula is negative b plus or minus the square root of b squared minus 4ac all divided by 2a. So negative b is 1 plus or minus the square root of b squared is 1 minus 4 times a is 1 and c is negative 8, all divided by 2a. Now, notice inside the discriminant, the square root symbol, we have two negatives. That's going to make a positive. So you get 1 plus 32 is 33. 1 plus or minus the root of 33 all over 2, and that's my solution. The next problem is, somewhat confusing sometimes for people. When you see a square root, what we do is we square both sides, and we get 2x plus 1 is equal to 9. Then when you solve, 2x is equal to 8, divided by 2, x is equal to 4. And all looks good, okay? But I have this problem here to make a point. If we plug 4 back in, watch what happens. You get the square root of 8 plus 1 is equal to negative 3. The square root of 9 is equal to negative 3. Now, this is a very confusing part for some people when it comes to mathematics. We say that the square root of 9 is 3. So, in fact, in this situation, we would say square root of 9 is not negative 3. This would be what we would call null solution. And here's why. So don't get too freaked out by this, okay? The fact is, if I ask you what the square root of 25 is, we are asking for what is called the principal root, or the positive root. We would say 5. If you're solving x squared is equal to 25, in this situation, you are saying that you are looking for 2 solutions. So when you square root, you're looking for 2 solutions. That's why we list the positive and the negative 5. So you have to look at the context of the problem. And in this situation, you have just the square root. And so you are just looking for the positive solution. In fact, anytime you have a square root like this, it can never be equal to a negative. So therefore, I know that the answer is no solution. In fact, if you went into your calculator and typed in square root of 2x plus 1, years past, you've learned how to graph square root functions. I zoom 6, zoom standard. You look at the graph that pops up. Does that graph ever have a height of negative 3? Let's see, y equals negative 3. Does the square root function ever equal the bottom function? Never. Never. You can see the square root function only has positive values. So again, I do understand why when you see x squared is equal to 25, you list, x is equal to plus or minus 5. That's because you're looking for 2 solutions. But if you're just looking at the square root of 9, we say that that is just 3. It's not attached to an x squared like in the previous problem. So just be careful of that. I'm not going to try to trick you guys. That's not. I'm not going to try to put problems like that for you on the test where I trick you, make up crazy stuff that you're really not familiar with. But I just want to continue to reintroduce some of those pieces because we're going to talk about them more as the class moves along. In this situation, I have a square root equal to that. I'm going to take square root of x plus 1. And I'm going to add the 3 over, and I get is equal to x plus 4. Now, there's no way we can get around this other than by squaring both sides. So we have x plus 1 is equal to x squared plus 8x plus 16. Subtract the x, subtract the 1. 0 equals x squared plus 7x plus 15. Well, that does not factor. I have to use the quadratic formula. Negative b plus or minus the square root of square b, I get 49, minus 4 times a times c is 15. I divide that by 2a. Look at what happens. You get 49 minus 60. And 49 minus 60 is negative 11. Anytime you end up with the square root of negative, we would say that is a non-real solution. Now, it is true that you can take out a factor of the square root of negative 1 and write it as I roots of 11. That would be acceptable as well. Either tell me that it's a non-real solution or show me that it's a non-real solution. But we do have non-real solutions that exist. Letter F, a cube root. Divide by 2. Cube root of x plus 3 is equal to 4. How do we get rid of a cube root? We cube both sides. And we get x plus 3 is equal to 64. Subtract the 3, x is equal to 61. If you were to plug it in, it would work. Just a little bit review some radical and rational functions that you've seen before. In this situation, we have functions that have what we call quadratic form. Quadratic simply means that it factors to 4 parts. So this can be written as x squared times x squared. And then what we have on top of that is we have a minus 9 and minus 4. So although it's not second degree to start with, that's what you think of when you hear quadratic, but it's quadratic in form in that it factors to these four parts that you see. So then we can factor to x plus 3, x minus 3, x plus 2, x minus 2 is equal to 0. And you can tell by the fourth degree that we're expecting to have four solutions. X is equal to plus or minus 2, plus or minus 3. There we have that. In this situation, we have 3x squared and x squared. A minus 1 and a minus 1. That's going to give us the negative 4x squared in the middle. Well, this is easy to factor. X plus 1 times x minus 1. This one, we don't really factor that. In fact, we solve it by setting it equal to 0. 3x squared equals 1. Divide by 3, x squared is 1/3. Square root both sides. X squared is equal to, let's take the square root of the top, we get 1. Oh, I'm sorry, wrote that incorrectly. We took the square root of x squared, so we have x equals plus or minus, the square root of the top is 1, and then the bottom, the square root of 3. If I rationalize the denominator, I get x is equal to plus or minus the root of 3 over 3. So our solutions are plus or minus the root of 3 over 3, and positive 1 and negative 1 from these two up here. So you can see, I thought I'd get four solutions, and in fact I do. Now, these may not look like they have quadratic form, but they do. I need two things that multiply to x to the 4/3. And because you're adding the exponents when you multiply, we have x to the 2/3 and x to the 2/3. X to the 2/3 times x to the 2/3 is x to the 4/3. Then we have a minus 4 and we have a plus 1. So let's solve these. X to the 2/3 minus 4 is equal to 0. If I add the 4, x to the 2/3 is equal to 4. What this is saying is the cubed root of x squared is equal to 4. So you're going to solve that. You're going to cube both sides to get x squared is equal to 64. And then you're going to square root both sides to get x is equal to plus or minus 8. In this situation, x to the 2/3 is going to be equal to negative 1. Or the cubed root of x squared is equal to negative 1. When you cube both sides, you get x squared is equal to still negative 1. And when you square root that, you become an imaginary solution, plus or minus I. So you'd say that x is equal to plus or minus 8 is your only real solution in that scenario. And even when you see examples that involve square roots, you can rewrite those as rational functions. X to the 1/2 minus 5x to the 1/4 plus 6 is equal to 0. So what you're looking for here as you factor is you're looking for two things that add to 1/2. And that'll be 1/4, 1/4. So x to the 1/4 times x to the 1/4 does make x to the 1/2. Two numbers that multiply to positive 6 that add a negative 5, got a negative 2 and a negative 3. Look at your equation. X to the 1/4 minus 2 is equal to 0. Or in other words, the fourth root of x is equal to 2. If you raise both to the fourth power, you get x is equal to 16. In this situation, the fourth root of x will be equal to 3. Take each to the fourth power, x is equal to 81. So in there, I have two solutions. A little bit longer video today. The last piece you're going to do is you're going to solve literal equations. Literal equations means that we have some variables and we solve for the missing variable. Very useful in science, and we are going to use this skill in math to come. This situation says solve for c. So I'm going to divide both sides by m to begin with. So e over m is equal to c squared. Square root both sides, and you get the square root of e over m is equal to c. Some people say list plus or minus. You can. You don't have to. So you can see that this is e is equal to mc squared. They know whether the constant should be positive or negative in this situation. So it really is in context of it. I won't mark it wrong if you don't write the plus or minus in that situation. If we want to solve for m, I'm going to multiply both sides by q squared. That's equal to t m g. Now I go ahead and divide through by tg. I get rq squared over tg is equal to m. That's my solution. Let's get a little bit more challenging. In this situation, it's difficult because you have x in multiple places. What you do is you first start by distributing. 2px minus 2r is equal to 3rx minus 12. The next thing you're going to do is you're going to gather your x's on one side. 2px minus 3rx is equal to 2r minus 12. So I brought the 2r over and I brought the 3rx over. Now I want to isolate the x because I'm trying to solve for x. As you isolate the x, factor the x out. The x is now factored out. In order to solve for x, divide by whatever remains. So in fact, x is equal to 2r minus 12 divided by 2p minus 3r. That is your solution. Last example, 3b cubed x plus 5 is equal to 4y minus 4x. If you add the 4x over, you get 3b cubed x plus 4x equals 4y minus 5. Factor the x out. That isolates the x from the rest of the equation. Finally, divide. X is equal to 4y minus 5 divided by 3b cubed plus 4. I want to be clear. If you were to gather your x's on the other side, your equation would come up a little bit differently. You would have come up with x is equal to 5 minus 4y over negative 3b cubed minus 4. And these are the same. And the reason why is the top and bottom are different by a factor of -1. As long as the top and the bottom are different by a factor of -1, then in fact the equation is the same because -1 divided by -1 is in fact 1. So this is the one that I would go with, the top one. That's what I did. But this assignment is a little bit more challenging. So hopefully you have some questions. You're ready to go. Have a great day, and we'll look forward to seeing you soon.